Hey everybody, it's Steve. I'm here to talk about takeoff warning systems in Part 25 transport category airplanes. Here are the topics. We're going to go over a little bit of Part 25, kind of the philosophy behind its introduction, and then we'll see where that is applied in a couple different aircraft types, a lot of Boeing and A320 and 50 as well. All right, so for Part 25. Federal Aviation Regulations Part 25 details the airworthiness standards for transport category airplanes, including requirements for flight characteristics, structure, power plant, and equipment. Back, especially in the introduction of the jet age, airplanes were getting a lot larger, starting to carry a lot more people, flying higher, faster than ever before, and of course, becoming more complex. The industry saw some accidents related to takeoff configuration, and that's where the takeoff configuration warning system actually comes from in part as a part of Part 25 of the regulations. Some other things, such as structure, design and construction, power plant, like what kind of engines that these aircraft can use, um, equipment, and then other operating limitations. Those are all included under Part 25, as well as the takeoff config warning system. All right, the transport category. I want to explain this a little bit just so we understand. I know a lot of people confuse category and class sometimes. So let's go over the transport category. So for airplanes, a few different categories exist in the regulations. They are normal, utility, acrobatic, commuter, and of course the transport. And then there are some special classes such as experimental and restricted. Limited is also another special class for certification under the FARs. And then I included over to the right multi-engine airplanes with more than 19 seats or a maximum takeoff weight greater than 19,000 pounds must be certificated in the transport category. So these are your, 737, 47, 67, and your A320, 18s, all that. So the typical airline transport airplane that you would see, follows these guidelines and are certified under the transport category. So specifically talking about takeoff warning systems itself. So if we examine Part 25 and go to 703, this was specifically added to Part 25 in around 1978. That was the docket number. And a little bit about it. Okay, a takeoff warning system must be installed and must meet the following requirements in order for an aircraft to be certified under the transport category, or 25. The system must provide the pilots an oral warning that is automatically activated during the initial portion of the takeoff roll if the airplane is in a configuration including any of the following that would not allow for a safe takeoff. Wing flaps or leading edge devices, such as slats, or I think there's also manual flaps in the front in some airplanes, or leading edge devices that are not within the approved range of takeoff positions. Number 2, wing spoilers, except lateral control spoilers meeting the requirements of 25.671. Speed brakes or longitudinal trim devices are not in a position that would allow for a safe takeoff. And 25.671, I believe, is covers like devices like flaperons, which is a flap and an aileron. And I think the 777 and 787 have those. But anyway, so you got wing flaps or leading edge devices, wing spoilers. So those are your ground spoilers and your multifunction spoilers. Then you also have your the warning required by paragraph A of this section. So that of this section must continue until the configuration is changed. Action is taken by the pilot to terminate the takeoff roll, or the airplane is rotated for takeoff, or the warning is manually deactivated by the pilot. So the pilot has to take action in order to cancel any of these. Now, 25.703, this is a pretty short regulation. It really only forces the manufacturer to check a couple things. We'll see in the latter part of the slideshow that all of these manufacturers take this regulation and push it a lot further to make for a safer condition, a safer flight condition, right? So Not only are they taking the regulation, but they're also pushing it a little bit further to make it even more safe. All right, starting out with the 737. I've got the cockpit plastered to the right. We're going to notice a commonality in all of these systems in the Boeing side of things. There is not a takeoff config switch so much. In my jet, there is a takeoff config switch, but in a lot of the Boeings, it is, I think all of the Boeings, you're actually going to initiate the test function of the takeoff config or the takeoff config test just by moving the throttle, right? You want to trigger the system to think that you are applying takeoff thrust in that condition, and then it'll check all of the systems. So the takeoff configuration for the 737 warning is armed when the airplane is on the ground. That means wait on wheels. And either or both of forward thrust levers are advanced for takeoff. An intermittent takeoff warning horn sounds if trailing edge flaps are not set in the flaps 5 through 15 takeoff range. And might want to mention that this is a 400, 500, and 600 model. The NG is 0 to 25 flaps. Leading edge devices are not configured for takeoff, so that'd be your slats. The speed brake lever is not in the down position, which is on the left side of the throttle quadrant there. So that needs to be forward, which means that they're not armed or they're not deployed. They're not up off the wing. The parking brake is set, or the stabilizer trim is not in the takeoff range. So we have our stabilizer trim over here. It needs to be in the green range for takeoff in most of the Boeing aircraft or all of the Boeing aircraft. And so again, we can see the first two per the regulation 25703 or whatever that was. It'll check flaps, slats, but also it's going to go further. And for a more modern airplane that has speed brakes, or it's going to check the parking brake and also the trims. The warning indication is canceled when the configuration error is corrected. So returning the trim to the green range, or moving the slat lever, or whatever it might be. Okay, 47 now, 747. Got the Queen of the Skies, they say, right? This is 747-400. That's the manual that I could find for this airplane. The manual is actually kind of hard to find, but anyway, the respective ICAS alert message config is displayed if. So now you're going to advance the throttles, and then you're going to check for the ICAS messages here in the center display or display unit 3. Left to right, number 3. Airplane is on the ground, and so wait on wheels. The takeoff config warning is armed, and then fuel control switches are in run position, and engine 2 or 3 thrust is in takeoff range. So you're moving the thrust levers 2 or 3 up to takeoff thrust. Airspeed is less than V1, and any of the following configurations exist: flaps not in takeoff position, or body gear not centered, or parking brake is set, or speed brake lever not in the down detent. Again, that's over here. And your parking brake, I believe, is right there, I think. Yeah. Let's see. Or the stabilizer trim, again, is not in the takeoff range. Your stabilizer trim is going to be over here on the captain's side of the pedestal. So, again, a lot of similarities. The 747 has more pairs of landing gear, so that was included in the takeoff warning, takeoff configuration warning. So takeoff configuration warnings are inhibited at V1. So if you continue past V1, the bells will turn off. If engine 2 and 3 thrust is decreased below takeoff range and airspeed is less than V1, but the airplane is still not configured for takeoff, the master warning lights extinguish and the siren is silenced. So your master warning is up near the guidance panel on the left side and the right side for the FO. It's going to be red, and those will extinguish if you continue past V1 and make past your takeoff decision speed and decide to go in the air. The config message remains displayed until the airplane is configured for a normal takeoff, and again, that'll be in the ICAS and display unit 3. Boeing 767 now, and this is not a great picture, but anyway, we'll roll with it. Establish one or more of the following conditions: flaps not in takeoff position, speed brakes not down, stabilizers units set greater than green band, parking brake set, and takeoff configuration switch in TO. So this aircraft actually does have a takeoff configuration switch, and I believe it is right here. Observe, master warning lights illuminate, siren oral warnings activates, config light illuminates, and that's, I believe, yeah, it's right here. Config would be right in here. That'd be a master warning in the red. This is your annunciator panel next to your standby instruments. Let's see. Applicable ICUS warning alert messages are shown. That'll be again in the center display units. Establish appropriate configuration and also I included that there is a test switch for this specific Boeing behind the FO seat on the right. So there's actually a panel back there that you can use to test the takeoff config warning system. Let's continue. For the 777, takeoff configuration warnings are armed when the aircraft is on the ground and thrust is in the takeoff range on either engine. Takeoff configuration warnings are also armed when the aircraft is on the ground and the takeoff check switch is pushed. Okay. Takeoff configuration warning messages include config doors, flaps, gear steering, parking brake, rudder, spoilers, and stabilizer. So you got your rudder trim, your spoilers deployed or not seated. Your doors are not closed and locked and armed, and a number of others there. Stabilizer trim just like on the other aircraft. All takeoff configuration warning indications are canceled when the configuration error is corrected. Additionally, takeoff configuration warnings are disarmed at V1. Any existing takeoff configuration warnings indications are inhibited above V1. So there you go. Now we got the Dreamliner 787. The takeoff configuration warning system alerts the crew that the airplane is not configured for a normal takeoff. The takeoff configuration warning function is armed when airplane is on the ground. Fuel control switches are in run position, so those are back here behind the throttle. Let's see. Either engine thrust is in takeoff range. Again, you're advancing the thrust levers forward. Thrust reversers are not unlocked or deployed, and airspeed is less than V1. Takeoff configuration warnings consist of illumination of the master warning lights and activation of the oral warning siren, and display of applicable ICUS warning config message. So again, those will appear on the, I believe on the pedestal display there. That would be the central display unit. And here are the warning messages. So kind of similar to the 777. We've got config doors, flaps, parking brake, rudder, spoilers, and stabilizer. So those all are checked through that switch. Now we're getting into Airbus. Airbus, from my research in the manuals, they have quite a bit of other things that they check, which is probably a good thing. When the takeoff config push button on the ECAM panel is pressed by the crew, it simulates the application of takeoff power. If any of the following parameters are not met, the associated ECAM warning message will appear. So that means you push this button before takeoff. It's probably in the before takeoff checklist if it's anything like the E170. And the takeoff config push button is actually going to be right down here. There's these four thumb switches here, and then you have a dimmer on the left, and the second one over from the right, or from the left rather, is the takeoff config push button. So that's going to run its test by simulating in the system logic that takeoff thrust is being applied, and it's going to check all of these things. So rudder trim, pitch trim, flaps not in takeoff config, speed brake not retracted, so deployed, slats, left and right side stick. So if your fly-by-wire has a fault message, door, so that's all of your passenger doors sealed or locked and armed. FWS OEB, I don't really know what that means, but anyway, brakes hot. You don't want to take off with hot brakes. We're limited to I think it's 340 degrees Celsius or something like that. Maybe it's less than that, 290 degrees Celsius in the E170, so I'm sure they have a limitation there as well. You shouldn't take off with brake temps in the amber or too hot. That would not be good. Then it's going to run a couple systems checks. Okay, fuel right and left, tank pump, 1 or 2 low pressure. And same thing with the hydraulic pumps and also the system pressure for the hydraulics. So if you forgot to turn on a pump, or an automatic pump failed, that would be something that you would see on the ICUS. I know in the E170 specifically, when you advance the thrust levers past a certain TLA, I believe it's 70 degrees, we have pumps that actually turn on automatically. So we have hydraulic pumps that start working automatically, and we have 4 on board, and we have 1 manual. Electric IDG 1 and 2 disconnected. If you don't know what IDG stands for, it stands for internal driven generator. This is basically an alternator off of the engine. So this runs on bleed air from the engine. It's got its own oil, and you have 1 in each engine. They produce alternating current, just like an alternator. And some systems, I believe the Airbus has this as well. A TRU, which is a transformer, will change the AC current into DC to charge the battery. So it's basically just a roundabout alternator in order to get charge into the system and have everything powered. So it's going to check those. So the IDGs, you got to have at least 2 sources of AC power on any commercial aircraft. So that could be your APU and 1 IDG or 2 IDGs or any combination of those. So it's going to check those, make sure they're getting the correct output. Electric generator 1 and 2 fault or off. Okay, so if the switch is off or if a fault occurred, it's going to check that. And then config parking brake, that's self-explanatory. And then engine thrust levers not set. So in the E170, we get a TLA angle disagree. That's our message. So in the Airbus, the engine thrust lever is not set. That just means that the thrust lever angle is not where it should be set for takeoff or go around. So if you're advancing the thrust down here, there's a detent that you have to leave it at, which would be takeoff or go around. And if it doesn't make it there, if it doesn't quite make it there, if it goes past, then you'll get the ICUS message, engine thrust lever is not set, right? So something is wrong with the thrust lever angle, that it is not set for takeoff power, right? Takeoff thrust. Next, this one is a whole bunch. It's for the A350, okay? Yeah, it's going to check all these things. And again, the concept is pretty much the same. You can see the takeoff config button even better here on the center pedestal. It's right here next, right behind the engine start, the engine controls. And you got red, which are master warnings, and then you have yellow, which are master cautions. And in this manual, I took a picture of the manual actually. It's just a QRH procedure, but all these things would basically constitute a rejected takeoff if you got to that point. So we have all those configs, the master warnings, and the hydraulic pressure. So if you have a loss of hydraulic pressure of some sort, and then all these, we have a lot of door warnings, we have a lot of electric warnings, and then flight control issues, and then something interesting that the Airbus actually has is takeoff runway too short. And it seems like you usually are more worried about that on a landing. I've actually seen videos of crews making an attempt to land, and then the French guy on the speaker comes over and says, landing runway too short, or whatever, so you have to go around. But anyway, and then a couple fuel things, and then there you go. So takeoff data, V1, VR, and V2, that would be a big one. And yeah, that's it. So here are all the manuals, and I used an AC in there for some of it. And I've got a A350 manual from Virgin Atlantic, Boeing Company 98, 92 for the 737, 300, 400, 500, and 747. Interestingly enough, the A318, 19, 20, 21, those are all the same manual from Airbus in 2017. And then LATAM Airlines Group, I got my 767 manual from them. Continental also had the 777, I believe. And yeah, that's it. Thanks for listening.